Good morning, everyone. Today we're going to wrap up section 4.1 with a couple of examples. If you recall, we were doing counting techniques using the multiplication rule and the addition rule. So let's get to our first example. How many 4-digit pins? A, start with a 9, B, end in a 4, C, start with a 9 or end in a 4, and D, start with a 9 or a 4. Now, just in case you're unfamiliar with what a pin is, that is a personal identification number just writing that down. It's a personal identification number. It's the 4-digit code that you type in at a bank machine or when you're using your debit or credit card at the store. So let's take a look at part A. If you want to try it for yourself, now would be a dandy time to pause the video and give it a shot. Okay, so for part A, we're going to start with a 9. We're going to use the multiplication rule here. It's a 4-digit pin, and any number can go in any of the slots except for our restriction. So in the very first slot, we have to have a 9, and any of the others are any digit, and any digit. So the number of choices that we've got for the first slot is 1. The number of choices for the second slot, because it could be any digit, is 10. And that's true for actually all of the remainder. And remember what the multiplication rule says is that if we have 1 choice for the first slot and 10 for the rest, then the total number of events here, or the number of ways that we could have, or number of different pins we could have, is just all of those multiplied together to give 10 cubed, or 1,000. Let's take a look at part B. Part B, end in a 4. Answer will be the same. But part C, we want to start with a 9 or end in a 4. And in order to do that, we're going to need the addition rule, which says that the number that start with 9, I'm just going to abbreviate that with start 9, or end 4, is equal to the number that start with 9 plus the number that end in 4 minus the number with both. Because some of the ones that start with 9 end in a 4, some of the ones that end in a 4 start with a 9, and we have to make sure that we don't double count. So we're going to do a little aside here. Just going to do a little box. And we're going to say we're going to first calculate both, because we already have from part A the number that start with a 9, and from part B the number that end in the 4. So now we're just going to say a number for both. There's 4 slots here, and there's a 9 in the first slot and a 4 in the last, and then any in the other 2. So there's 1 choice for the first, 1 choice for the last, and 10 in each of the remaining, and that's going to give us 10 squared, or 100. So going back to our statement above, we've got that number that start 9 or end 4 is equal to the number that start with 9, which we found in part A to be 1,000, plus the number that end in 4, which we found in part B to be 1,000, minus the overlap, which is 100. And when we add those together, or add and subtract rather, we get 1,900 different pins. So now for part D, we can do that exactly the same way. We can say that the number that, using the addition rule, the number that start with 9, make my handwriting a bit more legible here, 9 or 4 will be equal to the number that start 9 plus the number that start with 4 minus both. And we found that the number that start with 9 is 1,000. The number that start with 4 would be the same, or 1,000. And now we're going to subtract the number in both, but you can only start with a single digit. You can't start with a 9 and a 4, so there's no overlap here. And so we're just going to get 2,000. Now I'd like you to notice for this last one, you could use a different method. You could just say, okay, there's 4 different slots here, and we've got a 9 or 4 in the first slot, and so there's 2 choices, and then the rest you can have any choice, so you can have 10, 10, and 10, and that gives us 2,000. Now a good question is why we can use the multiplication rule for part 4 when we can't use it for part 3. And the reason for that is if you take a look at, for part 4, when it starts with a 9 or a 4, no matter what you choose for the very first slot, you're going to have the same number of choices everywhere else. But if you take a look up above and you say, okay, if I were to try to do, I'm just going to draw a little box over here just for illustration purposes, you're to try to draw a little box with 4 slots here. If you put a 9 in the first slot, then you could have anything in the last slot. But if you don't have a 9 in the first slot, then you must have a 4 for the second slot. And what that means is that the number of choices in the last slot is not independent of the number of choices in the first slot. And that's why you can't actually use that method for part C. Okay, let's do our last example of the section. And our example is how many 4-digit pins are there if repetition of digits is not allowed. And for our answer here, we're going to again use the multiplication rule. And 4-digit pins, you can have any choice in the first slot. You could have any of our 10 choices. But the moment you've picked one of them for your first slot, then you don't have as many choices for the second. The number in the second slot would therefore be a 9. Now you've used up 2 numbers, and you're only going to have 8 choices left for the third slot. And then for the fourth slot, you're only going to have 7 left. And when you multiply those all together, you're going to get 5,040. Just going to do a little digression here. This will not be tested. There's another way to calculate this. And as you probably guessed, it's through the use of factorials. Now you can see above that we had taken 10 times 9 times 8 times 7. And I think that you'll all agree that that's equal to 10 times 9 times 8 times 7. Well, that's obviously true, hopefully. But I'm just going to keep on multiplying here. 6 times 5 times 4 times 3 times 2 times 1. And of course that's not equal, so I'm going to divide by 6 times 5 times 4 times 3 times 2 times 1. And so that's equal to 10 factorial over 6 factorial. where the number of choices that we had was 10. We had 10 digits, and the number, so that's the number of digits, and the number of slots that we were trying to fill is 4. And then the numerator is just the number of choices taken as a factorial, and then the denominator is 10 minus 4 factorial. And I know that some of you may have done a little bit of statistics before. This is called a permutation. It's an ordered arrangement of choices taken without repetition. So you're not allowed to repeat something from a finite number of possibilities. And on your calculator, or at least most scientific calculators, it's the NPR button. And if you want to try it, you'd enter a 10 and then hit the NPR button and then enter 4 and then hit equals to get 50/40. And that wraps up our first example for a full example for the multiplication and addition rules together.